So this is my last instructional video for this course. I'm just trying to fill in the gaps. So, and this is the book. I think the book is really good, and I've been following the book pretty well. I've been teaching a little bit outside of it, but these are some topics that I haven't talked about, but I wanted to mention them specifically because they are on the standardized American Chemical Society test. So these concepts are on there, but not as well illustrated in the textbook. So I did mention strong electrolytes. I did mention weak electrolytes, but I wanted to give it a little more discussion with that. Weak electrolytes do not completely ionize, and they are molecular, so made of nonmetals, and they are weak acids and bases. So things like that's acetic acid, CH3COH, and ammonia. So these are the weak electrolytes. And yes, I remember I did talk about this. Multiple ionization energies. So whenever there is you'll see a huge jump in a ionization after an electron or after a noble gas configuration. So meaning, like if you have lithium, the first ionization energy is kind of low. Then the next one's going to be huge, a huge difference. So then, say beryllium, the first one's going to be smallish, the second one's going to be slightly bigger, and the third one is going to be huge because of the noble gas configuration. So that's the multiple ionization energy. Hydrogen bond, I usually talk about it in 162, but there's some hydrogen bond stuff on the test. So a hydrogen bond is when there's a hydrogen bonded directly to a nitrogen, oxygen, or fluorine, and then there's this attraction. So the idea, though, with the hydrogen bond is that nitrogen, oxygen, and fluorine are very electronegative, and they're very good at drawing electron density away from the hydrogen, which makes the bond particularly polar. So if you look at this, so these molecules here, there can be a hydrogen bond here because the hydrogen is directly attached to an oxygen. Okay, this molecule here, formaldehyde, has oxygen and hydrogen, but since the hydrogen is not directly attached to the oxygen, therefore there is not hydrogen bonding in that molecule. Okay, so water has hydrogen bonding, so does formic acid here because it has the hydrogen directly attached to it. And frequently it's shown by 3 dots for the hydrogen bonding. And we'll talk about this more in 162, but it's also it's how DNA zips together is with hydrogen bonding, at least the 2 strands of the DNA. Okay, so for reading something here, especially if you're not taking a lab class, you haven't learned how to read a graduated cylinder, but here if you look at this, what would this be? You can read it. So this is 30 right here, right? So I'm sorry, 30 at the bottom. This is 30. This is 35. This is 36. And from here, you can go to the 10th scale on this. So I see this as 36.7. It would be 36.7 plus or minus 0.1 milliliters. So you can read a scale and you can guesstimate it to the 10th place of the lowest scale. So, and I mentioned there the weak electrolytes and strong electrolytes. I guess I did talk about this as well. But so weak electrolyte tends to stay molecular, slightly ionizes. A non-electrolyte stays as a molecule. Strong electrolyte completely breaks apart. Okay, so short video, but I wanted to fill in those topics for you.